Hey, welcome to another exciting Java class where we answer the critical question, who is your daddy? Well, that's just a joke for something we mentioned in class, that the object class stands at the top of all of the class hierarchy in the Java language. So, I've given you this link and you can read through it, but I've also repeated the first line of this page, which is the object class sits at the top of the class hierarchy tree in the Java development environment. So every class in the Java system is a descendant of the object class, either directly or indirectly. So when you created a crab, its daddy was an actor, and actor's daddy probably was something else, but like eventually, if you went all up the hierarchy, which is a key word here, you would find the object class. So everything is descended from object. Think of it as kind of like a combined Adam and Eve for Java. Everything springs from that point. Well, we'll explore it a little more, except to say that every class that you write should have at least two ingredients. And we cover this in AP, but we're learning it here today. One of the things you should absolutely put in every class is an equals method. And basically, to summarize, an equals method allows you to compare two objects of the same type to determine whether they're similar or same. And what that means is that they share the same properties. Obviously, two things can't be the same. You need to evaluate whether they share the same properties. And likewise, the toString method is some method that should be put in every class because you probably want to display to the screen a representation of that class in the way that you would want. So let's dive under the hood and take a look in code board. You'll recall this class from the first assignment where I built out a customer having name, customer ID, balance, with a constructor that shared the same name as the class and the file, with parameter values that were used to set the instance information. We had a couple of accessors here, get balance, get name, and we had a mutator which updated the balance, taking in an item cost and adding it to the existing balance. So a customer from this point of view has a name, a customer ID, and a balance, and a couple of methods to either report out its information or to update it. Taking it over into main, I'm going to add something here, which is system.out.println x. So what would happen if I asked the system just to print out x, which is the object that I've created of the customer type? What would happen? Let me compile it first and show you. So we're looking pretty good, and what I want to do is pull up the screen here, if I can get it, okay? And looking for the double-headed mouse. Watch me as I fail, watch me fail, okay? What if I run? Maybe I'll do a little better here. Okay, there's the double-headed mouse. Okay, so right now it's prompting me to input a name, and I'll just go with Woodrow. I really haven't read that book very much at all. This is not a vacation. Next week will be a vacation, but Woodrow, and I'll hit enter, and watch, look. It outputs some strange thing when I ask it to output X, which is the name of the class and some number at 55F96302, at least on my computer. Okay, it will be a different number on your computer. Well, that's the memory address where this customer object is stored. And that may be useful for another type of programmer, but not for us. I want my object to output something different. So in order to do that, I have to override the object toString method. Because what's happening is when it asks to output X, it looks in customer and doesn't find the toString method and uses the object class. So what I'm going to do is give it a little more space. Hopefully I can get this down here. Watch me fail. Okay, and I'll scroll down and go public. Click in there. Public void. Well, it's not a void because it's going to return a string representation of the object, and it's very important to write it exactly like this. Okay, and what do I want it to return? I want it to return a string that has name. Maybe I'll just do something like this. The following customer. And I'll just put a little colon there, add a plus sign, and then write name, which is the instance variable, plus, and I will just move over here with an ID of, and then I'll add a plus and go cust ID. And then I'll go plus and move over here. Has a balance of, and I'll just quote and put a little plus sign here and say balance. And I'll close it right here and take the quote away. And I just want to double check that I've had the problem correct. So I really don't need that. I do need a quote there, and just get like a double one, just keeps on thinking. I may have forgotten a quote, probably a space here. I'm just going to go ahead and compile and let the compiler fix my errors if there are any. I'll take a peek, and there is an error. Let's see what it says. Okay, I see what it is. Look here, the plus sign's misplaced inside the quote. Okay, so I want to put a plus sign, and I really don't want this quote here. Watch me fall apart. I'll take the period away too. Got confused there. Let me compile and look again and see if I fixed the errors. So it's been successful, but watch what happens now that I have a toString method. Basically, when I run it here, and I'll just run it, it'll ask for Woodrow, and it says the following customer, Woodrow, with an ID of 1, has a balance of 1604. So that's pretty good, right? I've been able to control the way my object will output. And so I can simply put in the system.println the object name X, and it will work. So in order to create an equals method, I have to create another customer to compare it against. And so what I'm going to do is put customer, and I will not bother to ask for a name. I'll just say this is John, and the customer is 2, and the balance is 231. Okay, and I'll put a semicolon at it. Okay, and that's a colon, so I'll put a semicolon, and this time what I'll do is I will output system.out.println. Okay, and I'll go x dot equals y. Okay, and we'll see if we think this is good, I'll go ahead and compile it. Okay, and run it. So, and I run it, I'll hit, and it says it's false. They're not equal. Okay? And that seems like a pretty good answer, but basically what's going on is that they're comparing the memory addresses of X and Y. Okay? So that's not what we want to compare. Let's say we want to compare by ID. The fact that each customer has a unique ID and these IDs are different, so they're not the same. But what if I set them equal to be the same? That they both have a customer ID of 1. Okay, I'll compile that and then I'll run it. And I'll give you the exact same example, Woodrow, and it still says false, even though they have the same ID. Well, why I wanted to create two customers, X and Y, with essentially the same ID would probably put me out of business pretty soon. But let's go and fix that by going into the customer class and creating a new method. And that would be public Boolean, because it's going to return a true or false. You saw the output was true or false, equals, and what we'll take is another customer object. So we'll call this A, which when it's called will be Y. Okay. And what we're going to do is return, okay, cust ID equal A dot get cust ID. So there's a problem here, okay, which is that we don't have a get cust ID, which is the clearest reason why we do want one. And so what I'm going to do is just copy this and create one, which is Control V, and it will go ahead and return an int because it will be cust ID is an int, and it'll be returning cust ID. And so now that we have a way to report out the cust ID from a class, we can ask to get the cust ID from the parameter A. Remember, one customer doesn't know about another customer. You have to use the accessor methods that you built into the class in order to access information about the other customer. So cust ID refers to really X in the main, and A refers to Y, and in order to access the information about A, or in that case Y, from the X's working memory space, you need to call the accessor method. Let's compile. So I've been successful, and now I'll go to main and ask, do they equal? And again, I'll input Woodrow, and they equal because they both have the same customer number. But if I change this to 2, they should not equal, and let's test that out. Again, it's Woodrow. I gotta hit run. Again, it's Woodrow, waiting for the input. And they're false because the customer ID is different. So let's summarize. Everybody's daddy is the object class, and unless you override the toString and equals methods, you're going to get the results of toString and equals from the object class, which probably isn't what you intend. So in order to do that, you have to do something called override. And in the customer class, what we did is redefine the toString and equals methods so that they work the way we want them to work. And that is the secret. If your parent has some kind of blind spot, maybe a sin that they can't get over, maybe they don't like people from Easter Isle, maybe they don't like people from the Diego Island in the Indian Ocean, maybe they're a little bit xenophobic about folks from Tierra del Fuego. You can override that method. You don't have to be what your parent is about, and they don't have to be what you're about. And if you wanted to use their toString and equals, you could, but just as easily you can override them. And therein becomes some of the secrets of what they call the inheritance hierarchy. That a child class, customer in relation to object, does not have to be and do exactly as the parent. They can override methods. They can add new methods like getBalance and getCustomerID, which are not in the object class. They can build and enhance on the base platform that object class provides. And so this is it. The object class and how to override the toString and equals methods. Max